There are 4 of the exercises and problems that I wanted to go over with you. You may have more questions. Again, the solutions are posted for you in Doc Sharing. If you, even after seeing the answers, if you still have questions, just feel free to ask. But these are 4 particular that I thought I thought were rather challenging. So let's look at the first one. Clarence Weatherspoon, a super salesman contemplating retirement on his 55th birthday, decides to create a fund on an 8% basis that will enable him to withdraw $20,000 per year on June 30th, starting at the end of 2018 and continuing through 2012. To develop this fund, Clarence intends to make equal contributions at the year end 2014 through 17. So how much will this be in the balance when Clarence retires? So here's his retirement date, and he's going to pull out $20,000 for 4 years. 4 years. Obviously a very short retirement, but again, it makes the numbers a little bit easier. So when you go to your calculator, you're merely going to say, okay, we've got 4 periods, 8% interest rate. We want to compute the present value. Now, this may not be today in the time frame, but it is a present value lump sum for those future amounts. So at this point in time, we're going to take these future payments and determine what the present value of the lump sum at that point in time would be. We have payments of $20,000, and there's no lump sum future amount. So if you key that into your calculator, you're going to get $66,243. Okay, so that's going to lead us to the next thing. So now we know he needs $66,243 at the point of his retirement in order to withdraw these $20,000 over the next 4 years. Okay, now what we want to know is that if this is the time period where he's working, and again, the problem is keeping it really, the numbers easy, because obviously he would work more than 4 years to earn a retirement, and hopefully he'd have a retirement more than 4 years. But here's the question, how much needs to be set aside each year in order to grow the $66,243? So now that's $66,243 for this part of the problem. Again, we're only looking from here, here's today. So we're just looking from this point in time to here. So $66,243 is a present value. 4 is the number of periods. Again, 8% interest rate. There is no lump sum for the value today, and we are computing a payment. So key all that into your calculator, and you should get $14,700 would be the annual payment he would have to make. And of course, realistically, he'd be making monthly payments, so this problem keeps it somewhat simple that way. Okay, the next one, let's read through it. Black Knights Inc., a manufacturer of low sugar, low sodium, low cholesterol TV dinners, would like to increase its market share in the Sun Belt. In order to do so, Black Knights has decided to locate a new factory in Panama City. Black Knights will either buy or lease, I misspelled that, sorry, a site depending on which is more advantageous. The site location committee has narrowed down the available sites to the following 3 buildings. And keep in mind their normal borrowing rate is this 12%. Okay, so the first option is they could just spend cash of $600,000 today, and again, they would be able to use this building for 25 years. Option B is that they would lease it. So they would make $69,000 payments. Again, this would be at the beginning of the year, so that makes that an annuity due. And again, they would do that for 25 years, $69,000 for 25 years. Option B is pay $650,000 today, so instead of $600,000, $650,000. Well, why would they be willing to do that? Well, they might, they at least want to contemplate that because this would be a larger building, and they'd be able to sublet that extra space, and they're estimating they could get $7,000 a year for that for 25 years. So we have, both the present value and we have an ordinary annuity going on in option C. So let's go to the next page. First off, before we get to the next page, let's look at how do we compare. We have a present value here, we have an annuity due in the future here. We have a present value plus an ordinary annuity here. Well, in order to solve this problem, we need to, convert all of these amounts in the future to today. So we need to solve for, what's going to be the present value for that option? What's the present value of those future cash flows for option B? And what's the present value of these future cash flows for option C? I mean, we need, otherwise we're looking at apples and oranges and bananas here. They're all different. So we need to make the cash flow equivalent, some number where they're all equivalent. So let's discount all those back to the present, and then we can compare what's going on. So that's going to be our strategy. So let's do that. Well, in building, in the first option, it does have a present value. We already know. The present value is $600,000. There's no calculation necessary there. But in option B, and again, you want to make this an annuity due, so switch out your calculator. But we'll have, 25 periods, interest rate is 12, payments are $69,000, future value is 0. And then for building C, we actually have a couple of things going on. We have the $650,000 payment, so that's one present value. And again, let's go back and take a peek at this. We already have one present value. Now we need to solve for the present value of an ordinary annuity, and then we can add those together to get our combined present value. So we already know the present value of that. Now, of the ordinary annuity, that's going to be for 25 years, 12%. The payment is $7,000. There's no lump sum in the future, and we want to compute our present value. And that should turn out to be $54,902. Okay, so we want to net this together. So we've got $650,000 of cash that would be spent today, and then $54,000 that would come in the future. $54,902. Follow what I'm saying here? We're going to spend cash of $650,000 today, and then in the future we'd have cash coming in. The present value of that cash coming in is a positive $54,902. So the net present value is $595,098 for that option. You know what, I see on option B, I didn't compute my present value, did I? So let me give you what that would be. That present value, again, make sure you set up your calculator for annuity due, should be $606,606,118. So this option again, $606,108. And again, that's a negative because it's cash going out. So the present value of those future cash payments, $606,118. And then over here, the present value of the cash payment is $600,000. So which one would you choose? Well, you want to go with the cheapest option, right? So the cheapest option looks to be this one. Okay. And then we have exercise 11. Exercise 11 reads, So-so Excavating is purchasing a bulldozer. The equipment has a price of $100,000. The manufacturer has offered him a payment plan that would allow SOSA to make 10 annual payments of this amount, with the first payment due 1 year after the purchase. So that makes that an ordinary annuity. How much interest will SOSA pay? So on A, this is just checking to see, do you know the difference between, payments in the future and values today? So SOSA would pay this each year for 10 years. So the total payments in the future are going to be $162,745.30. Those are the total payments in the future. Now the present value is $100,000. Right? That's what SOSA gets today. SOSA gets the equipment with a value of $100,000 today, and in the future, those future payments are $162,745. So the difference of $62,745.30 is going to be the total interest cost over the 10 years. Okay. Now, on item B, SOSA has another option. Instead of, borrowing from the manufacturer, SOSA could go to the bank and borrow the $100,000. And the annual at a 9% interest rate. So SOSA could go to the bank and borrow at 9%. So now we're having to decide which is better, go to the bank and borrow or use the manufacturer. What we don't know with the manufacturer actually is what's the interest rate built in to this scheme. So let's go to our calculator. With the manufacturer, it covers, but N is going to be 10. We don't know the interest rate. We know the present value of what SOSA would be acquired from the manufacturer is $100,000. We know the payments are $16,274.53. And then future value is there's no lump sum. So key all that into your calculator and see what interest rate you get. And you should get an interest rate of 10%. So the manufacturer, offered out this payment plan for SOSA, but hidden in that payment plan is an effective interest rate of 10%. But SOSA can go to the bank and borrow at 9%. That's what SOSA should do. They should borrow at 9%. That's the cheaper alternative. Okay, problem 5. Problem 5 looks like it's got a bunch of different options going on with it, doesn't it? So let's read through and see what's going on. Julia Baker died, leaving her husband Brent an insurance policy. And he's got 4 options as the beneficiary. He could take $55,000 immediately. He could take $4,000 every 3 months for 5 years, $18,000 immediately, payable at the beginning of 3 months, $4,000, and et cetera, et cetera. Okay, so we need to figure out, again, we've got a bunch of stuff going on in the future. We need to solve for the present value of each of these alternatives. Then we can decide which one Brent would want to take. So in A, that one's pretty easy. That is the present value, isn't it? $55,000 is what he would get today, so that is its present value. For B, he'd get $4,000 a year, every 3 months. So let's see, every 3 months is a quarter for 5 years, so that's 20 quarterly periods. Let's see, they also give us a quarterly interest rate to make this a little bit easier. So 2.5% is our quarterly rate. So 20 quarterly periods at 2.5% quarterly. We don't know present value. N would be, let's see, that's for 5 years. Excuse me, I did N. What am I thinking? What have we got next? Payment. Payment would be $4,000. And again, there's not going to be a future value because there's no big lump sum in the future. So, you're left needing to solve for, 22.5, 4,000 and 0. What do you end up with? This should end up being 62,357. So option B, the present value, 62,357. So if I were comparing these two options so far, which one would you want? Well, I'd want to get 62,357 today instead of 55,000. So far it's looking like B is the one we want to go with at this point. Okay, let's look at C though. On C, we have immediate cash today. So, and then we have $1,800 every 3 months payable at the beginning. So we have 2 cash flows going on. We have one lump sum, $18,000 today, but we also need, let's kind of draw a line here, that's a lump amount, but we also have an annuity. So we need to figure out the present value of the annuity. Okay, so we have 10 years, and there's going to be payable every quarter. So there's 40 quarters in 10 years. Again, interest rate is 2.5 for every quarter. We don't know present value. The payment this time is going to be $1,800, and there's no future value. So calculate the present value off of that. So 40, 2.5, 1,800 and 0, and you should get something like 46,315. To get our total present value, you need to add these two together. Okay, so we're going to take the 18,000, so he gets 18,000 right away. And then the present value of the annuity he would receive is 46,315. So let's add those both together, and we'll get 64,315. So here again, if I compare my three so far, I'm really liking. I'm liking option C even better. Okay, let me insert another sheet because I think I'm going to need a little bit more space here to solve the option D. So on option D, if you read through it, it says he has $4,000 every 3 months for 3 years. So problem 5. So let's see if we could kind of draw that out. So here's your 1, and then we got a bunch of years, and then here's your 12. So he's going to get $4,000 for the first 12 quarters. Okay, so for the first 12 quarters, he gets $4,000. Then, starting in quarter 13, so see, so that for the next 25, so 12 plus, so for the next 25, so 12 plus 25 would give us 37. He's going to get $1,500. Okay, so again, we've got two different kinds of cash flows. He gets $4,000 for the first 12 quarters, and then starting in quarter 13, he gets $1,500. Okay, so we have two types of present value to solve for. We need to solve for the present value of the $4,000 annuity and the $1,500 annuity. So let's start with the $4,000 annuity. So here we have N, I, present value, payment, and future value. So N is 12, 2.5, $4,000 payment, and this is 0. So the present value of those $4,000 annuity, you should get something like $41,031. $41,031. Let's put that in. $41,031. Okay, so the present value of the $4,000. Now, what's going to happen on the $1,500 is that we need to figure out, when those start, what's the present value of that? So $1,500 for 25 quarters. So let's figure it out. So N is 25, I 2.5. You figure out the present value of a payment of $1,500, and there's no lump sum future value. So this time around, again, 25 at 2.5%, $1,500 payment, 0. You should get a present value of $27,637. Now, the thing is, that's not this present value. That $27,637 is actually at this point in time. So it's the present value, really, for year 12. So now we still need to take it, a step further, right? All the way back to today. So we need to figure out the present value of the 27,637. So again, N now is 12, right? Because we're here in year 12, so 27,637. Interest rate 2.5. There's no payment, but we do have a lump sum future value this time, 27,637. So there's no annuity payment. There's no annuity. So enter that into your calculator and solve for the present value, and you should get 20,555. Okay, so the present value of that is 20,555. So total present value for this option is 61,586. 61,586. Okay? So again, we had an ordinary annuity, and we had kind of this complicated deferred annuity. It's an ordinary annuity, but it's deferred. So we have to solve for, at the beginning of that first payment, what's the present value, and then that becomes a future value to discount back to the present. Okay, let's go back. On D, we said, all right, the present value of all of that was 61,586. So which option should he choose? C, the one with the most money. Okay? All right. Again, the solutions to the other remaining homework are posted for your viewing.